Hello everyone, welcome back to my YouTube channel. In this video, I will be talking about the laws of logic and their implementation. This topic is from discrete mathematics. So let us dive into the topic. So content for today's presentation is Introduction to Laws of Logic, the law of identity, the law of non-contradiction, the law of exclude middle, real world implementation, and the conclusion. Introduction to Laws of Logic. What are the laws of logic? The laws of logic are fundamental principles that govern valid reasoning, formulating the basis of deducing conclusion from premises in a structured manner. Significance in reasoning and arguments. These laws enhance clarity in the discussion and debate, ensuring that arguments are coherent, stable, and free from contradiction, which is essential for persuasive communication. Application in various fields. Laws of logic apply across discipline, including mathematics, computer science, philosophy, and linguistics, facilitating rigorous analysis and problem solving in diverse contexts. Overview of primary laws. Law of identity. This law states that an object is identical to itself, emphasizing the principle that any proposition is equivalent to itself, which is fundamental in logical reasoning. Law of non-contradiction. According to this law, contradiction statement both cannot both be true at the same time. This underpins logical consistency, where a proposition cannot be both true and false simultaneously. Law of excluded middle. This law asserts that for any proposition, either that the proposition is true or its negation is true, establishing a binary framework that is critical in logical evaluation and reasoning processes. Next one is the law of identity. The law of identity states that an object is identical to itself. Formula A is equal to A. This principle is fundamental to logical reasoning and philosophy, ensuring clarity in assertion. Real world examples. In daily life, the law of identity asserts that a person named John is John and not anyone else. Similarly, in identifying objects, a specific car is that a particular car and no other. Applications. Use in mathematics. Mathematically, the loss of identity facilitates operation and equations, such as identity function and identities with algebra, ensuring that values maintain consistency throughout transformation. Implementation in computer science. In computer science, the law of identity plays a crucial role in programming languages and databases, enabling object-oriented programming, which where each object retains its unique identity and properties. Now we come to the law of non-contradiction. Definition and science. The law of non-contradiction asserts that contradictory statements cannot both be true in the same context, underpinning the foundation of logical reasoning and disclosure. Example in logical arguments. An example of this principle is the assertion that A is B and A is not B cannot simultaneously hold true, highlighting its critical role in establishing coherent arguments. Practical implementation. Avoiding contradiction in reasoning. In problem solving and critical thinking, adhering to this law helps individuals avoid flawed reasoning, leading to clearer, more rational conclusions. Application in law and ethics. In legal and ethical discussions, the law of non contradiction helps ensure consistency in arguments, aiding in the resolution of disputes and promoting moral clarity. The law of excluded middle. Just a second. The law of excluded middle states that for any proposition, either that proposition is true or its negation is true, establishing a foundation principle of classical logic. Importance in binary logic. In binary logic systems, a law underpins the true or false value framework, ensuring clear distinction between option and enabling binary decision making processes. Examples and application: mathematical proof techniques and role in decision making process. Real world implementations: algorithms and data structures, programming languages. Algorithms are step by step procedures used for calculation and data processing, while data structures organize and store data efficiently for optimal access and modification. Programming languages uses logical structures to define and control the flow of programs, enabling the development of the software through coherent syntax and semantics. Logic in philosophy and science. Formulating scientific hypotheses and philosophy arguments. In scientific hypothesis, the process of creating scientific hypothesis involves logical reasoning to predict relationship between variables, shaping experiments and guiding research towards empirical validation. Philosophical arguments utilizes formula logic to construct coherent reasoning, helping to explore essential questions about existence, knowledge, values, and nature of reality. Coming to the conclusion part, importance of logical consistency. An exploration of why maintaining logical consistency is crucial for coherent arguments, effective communication, and overall integrity of an analytical framework. Future perspectives in the application of logic. Insight into emerging trends and technologies advancements that may reshape the application of logic in areas such as artificial intelligence, education, and problem solving methodologies. Thank you so much for being with me till the end of the video.